Okay, I apologize for not being able to be with you today. I had a kidney stone attack over the weekend and I've still yet to pass it. It's extremely painful and prevents me from being at school. We're going to talk today about multiplication of polynomials, and this is going to take into account a lot of things that we've already done. I just want to quickly review those. We're going to use regular multiplication for the coefficients and use all of our exponent rules that we've been working on the last 2 or 3 days. It's also important for you to be putting in those unwritten ones. We've talked previously, and we'll talk again today, about drawing arrows for the multiplication. We'll use the distributive property to multiply equally to all terms. And our final answer, remember, has to be in standard form. We've talked about that as well, and I'll go over that as we go. Make sure you pay attention to the signs, especially when you get into the binomials and trinomials. All right, we're going to start out here with some multiplication of monomials. Remember, monomials are one term. Terms are separated with addition and subtraction signs, so none of these are going to be separated. They will all be monomials. And one of the big things, you're going to multiply the bigs, those are the coefficients, and you're going to add the smalls. Those are the exponents to each variable. So if we talk about this, we're going to multiply 5x squared times 4x cubed. We're going to multiply 5 times 5 and get 20. And then we're going to add the exponents on the x. Now over here on number 2, we've got a couple things going on. Number 1, I need to put in this unwritten 1. And I'm going to multiply the 3 times the 3, multiply the bigs, and then I'm going to add x squared times x to the first and get x cubed, y cubed times y to the fifth. Again, these are the smalls, those are the exponents. I'm going to add those. The last example has some more of those ones I need to put in. I need to put in a 1 here, a 1 here, 1/2 times 1 times 6. Half of 6 is 3. A cubed, a squared gives me a to the fifth. B to the first, and b squared gives me b cubed, and then I have a c squared. Here are 3 examples for you to try. I'm going to pause this and let you try those, and then I will pick up in just a second with those answers. Okay, these should have been the answers you got for those. Hopefully, I know that's a short period of time on the film, but pause yours when we get through some of these you try things, and we're going to have those throughout. One of the other things I wanted to point out here is I hope that you, on the ones that you tried, put in those unwritten ones. It's going to make it so much easier for you folks. Now we have a polynomial times a monomial. Remember, a monomial is one term, a polynomial can be 2 or more terms. Very important here that we put in the unwritten ones. And now we will draw more arrows because we have more terms to draw it to. We're drawing from the outside, 5 times 2x squared, multiplying the bigs, I get 10 times the x squared. There's no terms on the outside to add to those on the inside. Multiplying the 5 times the 1x. 5 times 1 is 5 because those are the bigs, times the x to the first. And 5 times 4 is 20. There are no variables there. Similarly, here with number 2, I'm going to put a 1 in, a 1 in, and a 1 in. And I'm going to multiply this mess, 2x squared y, another 1 there, times 3x. 2 times 3 being 6. Adding the 2 and the 1 makes a 3, times the y. Don't forget that y. I now have to multiply it times the second term. Again, doing the same thing, but paying attention to signs. 2 times -1 is -2. X squared, there's nothing to add those 2 x's to. y to the first and y to the first makes y squared. Now you're beginning to see the signs here of why I've been so insistent on not using a calculator to add and multiply these integers. You can't be going back and forth and make any sense of it. Third example here, I'm going to put a 1 for a coefficient, a 1 for an exponent there. And I'm going to take 4a times this first term. 4 times 1 is 4. A times a squared is a cubed times the b. Then I'll multiply this. 4 times 2, 4 times positive 2 is a positive 8. I have 1a and I have b squared. Again, I'm putting these in standard form, alphabetical order with respect to degree. Taking care of all the a's before we take care of all the b's. Taking care of all the x's before we worry about any of the y's. Here again, you have 3 examples I would like for you to work. Again, I'm going to pause. It'll be a short pause, but you take as long as you. I'm not sure if that was pause there, but similar to your examples previously, I want you to put in the 1s and the coefficients and the exponents everywhere. Binomial times binomial. I've told you over and over and over, math is very simple, and then we start putting more crap in it. We're going to use the distributive property here, but we're going to distribute twice, and I'm going to show you what I mean by that in just a second, okay? It's not a hard process, but it is something that we've not done to this point. All right? So I'm going to take this x, I'm going to put a 1 in, and I'm going to multiply x times x. 1 times 1 is 1. X times x is x squared. And then I'm going to take 1x times negative 5. And negative 5 times 1 gives me negative 5. Times the x. I then am going to distribute under. I'm going to take this positive 2 and I'm going to multiply it times this large 1 times the x to the first. And this 2, a big number, times a negative 5 and get negative 10. Now, this brings about the point that, hey, you got some stuff here that is like terms. Like terms. So we got to address that. These two in the middle, after I multiply and divide in PEMDAS, I add and subtract. So I'm going to put these two terms together because they have the same degree. They have the same degree. Also, you'll notice that the first term is x to the second degree, which is a higher power of these two. Putting these two together, I get negative 3x to the first. This being a higher power of x remains out in front. This being x to the 0 power becomes the last term. Okay? So not much to that, but a little trick of the trade. As is there with this problem right here, just kind of a trick. And again, I know I do this in the past, and I'll do it again today. This is kind of a start example for you. X plus 5 quantity squared means the same as x squared. There's an x times an x. It's that number times itself, which tells me that this is an x plus 5 and an x plus 5. There are two factors that are x plus 5. When I have that, I can see that it becomes very similar to this one. I need to put in the unwritten ones. And then I will distribute twice. Once over the top. Well, I shouldn't have done that. Once over the top. And then once underneath. Again, I think these arrows are very important to help your brain process, keep you from getting ahead of yourself, reminding you it's 5 times 1 and 5 times 5 for the 25. Again, we see in the middle, if we put in all the unwritten ones, there are 2 terms in the middle that are of the same degree, that are like terms, so they need to be put together. Our final answer, again, is going to have an exponent of 2 as the highest degree. 5 and 5 makes 10, x to the first degree, plus 25. Finally, in this group of binomials times binomials, we again have 2 binomials that need some work. Putting in this one and the exponent, this one and the exponent, and an exponent there. Distributing over the top, multiplying the bigs. (3a to the 4th). 3 times negative 2 gives me negative 6 times a squared times b to the 1st. And then I distribute the other number, the negative 1b. And again, this is a problem where I need to pay attention to the signs. Negative 1 times 1 is negative 1. A squared b, because a has a higher power of x. And then negative 1 times negative 2 makes a positive 2. B to the 1st and b to the 1st makes b squared. Again, it's a thing where I am going to add these like terms in the middle, like so, and put them together as 3a to the 4th. Minus 6 and minus 1 makes minus 7. These are like terms that have a squared, b to the 1st. And finally, b of the highest power, but one that does not involve an a term, so it comes third. Okay? Again, I'll pause this for you to try these next 3. I'll let you see those before I pause it. All right, here are your answers for those 3. I have one more thing to show you, and again, it's going to be more the same, just more stuff on the inside. Again, this is something I've told you over and over and over again. We start with something very simple, and then we just put more and more stuff inside of parentheses. Polynomial times a polynomial. It's more than a binomial, it's a trinomial, so we just say polynomial times polynomial, and I'm going to put in those ones. Distributing twice. Once times 1x times 1x squared is 1 times 1, and then add the smalls. 1 times negative 5 is negative 5. X times x, add the smalls and get x squared. 1x times 4. 1 times 4 is a positive 4 times the x to the 1st. Now I'm going to distribute the positive 2 on the underneath side. Positive 2 times 1 is positive 2 times the x squared. Positive 2 times the negative 5 is a negative 10 times the x to the 1st. And positive 2 times the 4 gives me a positive 8. Now, as we showed you the other day, we're going to use our underlining technique to combine like terms. Looking through here, I see x cubed as the highest power of x, so I'm going to underline it one time. X squared is the next highest power of x. A negative 5 and a 2 makes a negative 3x squared. Now I'm looking at x to the 1st degree. 4, positive 4, and negative 10 makes negative 6x. And then I have the 8 out here at the end. X to the 0 degree. 3, 2, 1, 0. Standard form. Don't forget, you got to put your answers in standard form. Similarly, we're going to look at number 2. And again, put in the ones that need to be there. There aren't many. Again, multiplying over the top, bigs times the bigs gives me negative 6x to the fourth. Multiplying 3x times 3x to the first, or 5x to the first, is 15x squared. 3x times negative 6 is negative 18x. Now I'll distribute underneath. Negative 4 times negative 2x is a positive. Negative times negative is a positive. X cubed. Negative 4 times 5 is a negative 20x. And negative 4 times negative 6 is a positive 24. Similarly here, we will look at the exponents. We have several powers of x. We'll scan through there and find the highest power of x. And generally speaking, it sets out in front. Not always, but most of the time. Negative 6x to the fourth. There is one term that has x cubed. There is one term that has x squared. There are two terms. Negative 18 and negative 20 makes negative 38x, leaving me the positive 24 at the end. So two pretty good examples there. Lots of multiplication, lots of things going on. I want to do one more for you, and this one right here. Putting in the unwritten ones, and then distributing over the top to get 2x cubed. Again, multiplying 2 times the negative 6 gives me negative 12x squared, because I'm adding the smalls. 2x times 5. 2 times 5 is 10 times the x to the first. Distribute underneath, taking a positive 3 times 1x squared gives me positive 3x squared. Positive 3 times negative 6 is a negative 18x. And positive 3 times a 5 is a positive 15. Looking through here, looking at the numbers, highest power of x is 2x cubed, negative 12x squared, and positive 3x squared is negative 9x squared. Highest power of x, those are both ones. Positive 10, negative 18, negative 8x to the first. And finally, I have the constant of plus 15. All right, that's all for me today. I am going to ask you to do these last two. I will provide answers to that after a short pause. So if you want to pause yours and make sure you can do that, that'd be great. Here are your answers, and you can pick up your assignment on Canvas. This will be posted to YouTube, and the link there will also be on Canvas.